Hello. Today we are going to be talking about the triangle sum theorem. First, we're going to start with a few definitions. The interior angle is any of the angles inside a polygon. An interior angle forms a linear pair with an exterior angle. Remember, a linear pair is two adjacent angles and they are supplementary, which means they add up to 180 degrees. The exterior angle of a polygon is any angle formed by two sides of the polygon, one of which extends outside the polygon. Each interior angle of a polygon forms a linear pair with an exterior polygon. So that's really important. Make sure that the interior angle has to form the linear pair with the exterior angle in order for it to be an exterior angle. A remote interior angle is an angle inside a triangle that is not adjacent to a given exterior angle. And I will show you what that looks like here in a second. Okay, so the first thing that we're going to do is just review a few of the angles that you should already know. An acute angle is anything less than 90 degrees, so it looks like that. An obtuse angle is anything greater than 90 degrees, and it looks like that. A right angle is exactly 90 degrees, and a straight angle is exactly 180 degrees. So those are our four main types of angles that we look at. Okay, the triangle sum theorem says that angle 1 plus angle 2 plus angle 3 have to equal 180 degrees. So for example, if we have 70 degrees and 80 degrees right here, then we know that this 70 plus 80 plus this side, let's say it's x, have to equal 180. So we'll say 70 plus 80 plus x have to equal 180 degrees. Okay, 70 plus 80 is 150 plus x need to equal 180. So we'll subtract 150 from both sides, and now we know that x equals 30. So this angle is 30 degrees. For this triangle right here, we have these two lines, and if you'll remember, these lines right here mean that these sides are congruent. So these sides are the same length. When we have a triangle that has two of the same lengths, we know that it's an isosceles triangle. Okay, when it's an isosceles triangle, we also know that it has two angles that are the same, and those angles that are the same are exactly across from the sides. So this angle and this angle are exactly the same. So we know that 50 plus these two angles have to equal 180. So in order to do this one, to find out what these two angles are, first we're going to take 180 minus 50, and that means it's 130. So we know that 130 has to be divided up between these two. So then we're going to take 130 divided by 2, and we know that each angle is 65 degrees. This last triangle is an equilateral triangle. Okay, we know that because it has three of these lines on all three sides. So we know that all three sides are equal. And if we know that all three sides are equal, we also know that all three angles are equal. So if this angle is 60 degrees, we know that this one is 60 and this one is 60 as well. And if you think about it, it makes sense because 60 plus 60 plus 60 is 180, which is true. Our triangle has to add up to be 180 degrees. A review real quick of vertical angles. Remember, vertical angles are congruent and they're angles that are opposite of each other. So y is a vertical angle of u, 4 and 3 are vertical angles, 5 and 6 are vertical angles, w and z, x and v, and 1 and 2. The exterior angles that we talked about earlier, remember, that was where two sides of the polygon meet and they form a linear pair with an interior angle. So our interior angles right now are y, x, and z. So the exterior angles then would be the two angles that form a linear pair. So 3 and 4 are exterior angles of y. 1 and 2 are exterior angles of x, and 5 and 6 are exterior angles of z. U, W, and V are not exterior angles because they are vertical angles. They do not form a linear pair with the three interior angles. That's why I was saying earlier that it's important that you understand that they have to form a linear pair, meaning they have to add up to 180 to make a straight line. Remote angles are the angles that are opposite of the exterior angles. So for the exterior angle 5, the remote angles then would be x and y. Okay? Also for 6 as well. Okay? 5 and 6, the remote angles are x and y. For 1 and 2, the exterior angles are y and z. And for the exterior angle 3, the remote angles, 3 and 4, the exterior angles are x and z. The exterior angle theorem says that the exterior angle is equal to the sum of the remote angles. So what that's saying is that x is equal to the two remote angles, which in this case are 65 and 40. So x is equal to 65 plus 40. So x would equal 105 degrees. Now remember, we also know that, that the exterior angle forms a linear pair with the interior angle. So if we think about this theorem, we know that it's true because 65 plus 40 is 105. And remember, our triangle sum theorem says that the interior angles have to add up to 180. So if we take 180 minus 105, that's going to equal 75 degrees. So if we know that this is 75 degrees, then we know that this one has to be 105. So that's why that's always true, why these two add up to equal this one. So here's another one right here. If we know that the two remote angles add up to equal the exterior angle, then we know that 70 plus y is going to equal 120. So we would just take minus 70 and y is going to equal 50 degrees. The exterior angle is equal to the sum of the remote angles, okay? So now, same thing. Here, our exterior angle is 110, right? See, because it's on the outside. So we could say that 65 plus a equals 110. Okay, and then we could say minus 65 from both sides. And that is going to equal 45 degrees. So A is going to equal 45 degrees. Now you could also look at it this way, okay, because remember we know vertical angles as well. If you forget about the exterior angle theorem and you're given something like this, we know that vertical angles are congruent. So we also know that this is 70 degrees, right? So if we add 70 plus 65, we know that that equals 135. So then we can take 180 minus 135 and get 45 again. So that would be another way that you could go about doing it. And that is all for triangle sum theorem.